Welcome to episode 107 of my ordinarily dissected member, Scattered Thoughts. These are connected member. I'm talking about artificial intelligence. If you haven't watched something before that, I suggest you go back to episode 104 and come up to the present because these things are connected. Basically, in 104 and 105, I talked about computers, how they simply store information that we've translated into zeros and ones, which are an expression of actually transistors which have charge or no charge on them. I talked about the four stages of artificial intelligence. There's the pre-training, the training, the post-training, and reinforcement training. And in the last session, 106, I talked about pre-training, which is basically scraping the internet for all the information you can get and translating it into zeros and ones, binary numbers, in a linear string that comprises, talking about just English language now, about 500 billion words. Everything that's been written in English on the internet with some selectivity there of excluding certain sites. So that's called the pre-training. Now what happens? This is the key part, okay? And it's very complex, and I don't understand it in its complexity and its detail, but I do understand the concept. It's got this string of tokens, okay? And so it's going to take, let's say, 10 tokens, randomly chosen from the string, tokens 1 through 10. And then it's going to ask the question, which token is most likely to be following these first 10 tokens? So it goes through the entire billions and billions of tokens that now are stored, and it looks for that string of 1 through 10. Boom, it finds one. What comes after? Okay, that's a token. It's one of the 200,000 language tokens, okay? Boom. When it's finished going through the whole set of information, it's going to say, well, if you got these 10 tokens, the chances of the 11th token being this one is 1%, this one 4%, this one 0%, and so on. It tells you statistically what is the next likeliest token, okay? And then it'll say, well, let's take these 11 and find out what statistics for the next token to be, okay? And basically it goes through this all this data, massive data, multiple times to determine statistically what are the likely next tokens you're going to find if you get these tokens as a so-called context. And of course, these tokens can be made into words. And so, just take something very simple, 2 plus 2, the word 2, word plus, word 2, those are tokens. And it's going to go through the whole thing. And what's the likeliest next token? Is, right? Now it's going to take that and go through the whole thing again. And the next likeliest token is going to be 4. So is it thinking? Is it intuiting? Is it making a mental process? No. This is a statistical pattern recognition process by which these computers are determining what are the next likeliest tokens given a context of X number of tokens. That's what it's. And how does it? Okay, that's what it's doing. Here's the really tricky part, and here's the part that's really, really complicated. It's called training, because human beings are going to determine whether the result makes sense or not. Okay, so let's take one like 7 times 9 equals 63. They take these tokens and they analyze them to find out if 6 plus times 9 equals what the next token is going to be. And they put that through what's called a neural network. It's related to neurons in our own brain, uh, but not as powerful because our brain has memory as well as processing ability, where these neuron things don't. But look at it this way. You take all these tokens and you put them into a tube, if you will, and you mix them up, you process them, and you make them all related. Each token related to every other token in there. And then process it again, where all those tokens are re-related to the same number of tokens. You got all these relationships of tokens, and each one corresponds to a weight or a formula. So you have these complicated mathematical equations that you can adjust, okay? And so you put these tokens into this tube, into all these nodes, which are contained other nodes, which have connections which can be modified. The weights can be modified, the formula can be modified, and it comes out at the end. And so you start and you say 6 plus 9 equals, well, there's a 5% chance that it's 63, and there's a 7% chance it's 91 or something like that. And so that's not right. It doesn't come out the right answer. And so they tweak all these, they're called parameters. There's billions of parameters. So these tokens are going through this space, if you will. And as they go through it, each level is related to the way it comes from the previous level. Each node connected is given a weight, given a formula, and it doesn't come out right. So they go through it again and again and again, and they randomly change these weights, these formulas, until they come out with the right answer. This is called the training. So what's happened, again, statistically, is that in this device they're using with the billion parameters, they've been tweaking these parameters until they finally come out with the answer they know is the right answer. So now it's called a base model. It's called a base model. Now you got your artificial intelligence machine, if you will, a bunch of connected computers, and it's been trained. And what does it actually do? You can summarize it by saying it's an internet text token simulator. That is to say, with all these texts in the internet, if you put into the system your own text, it will go through and look at all the instances of that text you put in, and it will then give you the most likely next word and next word and next word and create a sentence out of it. So what is it doing? It's not thinking. It is taking the text that you enter. It's like an auto complete. You know, when you go on the internet and you to the search engine and you start typing this way, it'll start to complete what you've written there. It's exactly the same thing. The machine, if you will, has gone through the entire content of internet data. And when you put in a text, it predicts what the following text will be. And sometimes it's right and sometimes it's wrong. But it doesn't know whether it's right or wrong. You have to decide whether it's right or wrong. So that's called the training session, okay? Just to give you a brief kind of view of what's coming next, this is not very helpful in terms of answering questions. You want to have the ability to say, to ask a question, how many, what's a cat, what's the population of Yemen, You want to answer a question. So that's going to be the third stage in the process, the stage called post-training. We'll see if that works. And then there's a fourth stage called reinforcement training. But that's anyway, this is about training. What does training do? It takes all the data you've got on the internet, it goes through it, processes it, and creates a base model which will autofill, if you will. If you put text in, it will give you statistically what's the most likely following text of that. All right, talk to you next time.